Thank you guys again for checking in before class to get some notes and get us situated so that we can maximize our time together rather than just sitting there listening to me talk. So, what are we doing today? Last class, we were discussing displaying and summarizing qualitative data, categorical data. But what happens if we have quantitative data instead? How do things change? Well, when we have quantitative data, basically it's usually tons and tons and tons of numbers. So we like to summarize the data in order to help us look at large sets, because we're not interested in statistics in the individual values. We're more interested in the sample statistics that we get to try to estimate our population parameters. Without the summaries that we get from looking at our data, it's very hard to tell what's actually going on. We might think the average is one thing, but if all you're talking about is average or mean and you don't notice outliers or other things hidden within your data, it's hard to understand exactly what's going on. So, I know, surprise, 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 the best thing to do is make a picture. And you're going to be making pictures and making pictures and making pictures. The pictures here are a little bit different than what we had in the categorical data. How are they different? Well, bar charts, pie charts, all of those are talking about breaking things up by category. But we don't have multiple categories when we're talking about quantitative data. We're usually talking about one concept: height, weight, time, whatever it is we're examining. So when we have histograms, the first thing that we do is we take a look at our entire span of values, from the very smallest to the very largest. And we divide that range, and that's the term that we use, the range, into equal width piles, and we call those piles bins. Now, you need to make sure that you're careful about how you break up your bins, because you want to make sure that you're counting by something that makes sense. We normally don't start counting at 142 and count by 18. We might start counting at 100 and count by 50s. So it's important that our bins are smartly chosen, because when we look at this, depending upon how we identify them, the distribution of our quantitative variable might change slightly or a lot. So when we're looking at two things, a lot of people get confused with histograms and bar charts. What's the difference? Well, here you see a bar chart on the left and a histogram on the right. Both of them are going to have values along the y-axis, but in a bar graph, those are either going to be frequencies or totals. This here is a frequency, even though it says money, it's how many dollars, so it's a frequency of dollars. Over here, it's a frequency of values within this number range. A big hint with bar graph versus histogram, if you had no labels, is that a bar graph is going to always have gaps between its bars, where a histogram typically butts up next to each other along the side. In a bar graph, one of your axes is going to be your categorical variables. They're not necessarily going to be numbers. Is it possible to have numbers here? Sure. Maybe my categories are the number of violent crimes in a town by certain years. And we'll do each year will be a different category. The argument could be made there that it could also be a histogram, but it's all in how you approach things. Now with a histogram, this axis is going to be your number ranges. I'm not specifying X and Y axis because these graphs can be drawn to really go whichever direction you want. But know that in this class, when we're talking about histograms, we are always going to include the lower value and go up to, but not include the higher value. So this bin contains everything from 100 to 149.9999. But 150 picks up into this one. So you see gaps, it's a bar graph. No gaps, histogram. So every time we go to draw any type of diagram, you always want to start by thinking about what your situation is. Now, there is a condition, and as we go through this class, we're going to see that we have a lot of these assumptions and conditions that need to be met before we're allowed to proceed. Well, if I'm going to be talking about quantitative data, Well, that data has to be quantitative. And quantitative data typically is associated with units. So make sure you know what those units are. Now, sometimes we don't have units. For example, we talk a lot in this class about GPA. GPA doesn't really have a unit that goes along with it, but we call it GPA as its own unit. Now, when we're talking about quantitative data, we pick up a few more descriptive items that we get to talk about. So quantitative data, we're always going to be dealing with shape, center, and spread. And we even throw an extra one in there for good measure, unusual features. And depending upon what your data looks like, we go about describing the shape, center, and spread in different ways. But no matter what, if you are told, describe a distribution, you want to make sure that you always include those three things. And when we're describing it, if you have numbers, I want a number that matches to the center and the spread. Shape, you're normally not going to have a number with that, but center and spread, you need to tell me the numbers and the labels that go with them. So what kind of shapes are there to pick from? And that's really what we're focusing on here today, is just the shape. So we look at our humps, kind of like Susie Camel has 2 humps. How many humps does your histogram or stem and leaf plot, dot plot, whatever it is, how many does it have? And these distinct humps in a histogram or any of those others are all called modes. Modes meaning it happens more frequently than those surrounding it. So if you look at this graph, we see a clear spike and then a dip, a very significant dip before we come back up. That means that we have 2 modes here. You want to be careful. When we're looking at a graph, if you have to ask yourself, I'm not quite sure, are those 2 separate modes? If you're asking yourself that question, the answer is probably not. I don't even have to think about it with this one. I see a clear drop down where it goes down and then it comes back up. So this here has 2 modes. It is bimodal. A graph with just 1 mode is unimodal, multiple modes, multimodal, and no modes, where it's nice and level, that is uniform. And again, if you're looking at this going, I don't know, are those 2 modes? Are those 2 different peaks? The answer to that question is probably no, they're not. This guy, there's no distinct difference between the heights. Now, if you had this taller one sitting right next to the shorter one, maybe you can make an argument. But this is a uniform graph versus a bimodal graph. So continuing with the shape, we have how many modes, and we have whether or not it's symmetric. Symmetry is the idea that you can fold the shape down some line and the 2 sides roughly match. It doesn't have to be perfect, but it has to roughly match. And again, if you have to ask yourself, I don't know, I can't tell. If you can't quite tell, usually the answer is no. For the most part, our roughly unimodal and symmetric guys will be pretty obvious as to what's going ahead. But again, you're looking at that idea of folding it in the middle, and it should generally kind of overlap each other. If it's not symmetric, then we call it skewed. Now, the idea of skewed, people get mixed up a lot of times because skewed isn't about where the most of your data is, it's where the tail of your data is. Consider your tail something that someone is grabbing onto and pulling the graph in that direction. The direction of that pull tells you whether or not you are skewed left or right. So if you look here, it's not about where the majority of your data is, it's about these guys. Someone has grabbed a hold of this and pulled my table or pulled my data towards the lower values. Lower values, skewed left, always, no matter whether my graph is going up and down, left and right, doesn't matter. If the tail is pulling towards the lower values, we say skewed left. If my tail has been grabbed and it's pulling my data this way, towards the higher values, we call that skewed right. The reason why we call that skewed left and skewed right versus looking at where the humps are is because what it's going to do to our measurements of center. And we're going to go into that during class. But for right now, skewed left means the tail is towards the lower end of the values. Skewed right means your tail is towards the higher end of the values. And think about it in terms of that, lower values, higher values. Now, there's always an importance to note if you see something unusual in your graph. Now, what could be considered unusual? That's really anything that just doesn't match the pattern. Like one of these things does not belong, or one of these things is not like the other, one of these things does not belong. That's what we're looking for. They could be stragglers. Outliers is the technical term for that are going to be away from where your main data is. And we'll show you a calculation in class as to how you actually define and identify an outlier. You're going to be looking for gaps. So that's where we're looking at a space between histograms where there is no data. That can be very influential. So here you can see in this problem, I can call this several different things. I would not call this symmetric because it does not fold onto itself. I would call this unimodal, skewed left, with a gap between whatever these values are. And I would say it probably has a couple of outliers here, probably 3 outliers on this side. These are things we want to make sure that we always talk about. And notice again, just like our categorical data, we're going to have both axes labeled, units marked to give us a scale, and we're missing titles here, but that's because you don't have the context of the problem. All right, so when we're talking about describing the distribution of quantitative data, the idea of shape has many different things that we're going to talk about. Shape includes modes, so that's how many peaks does your data have, 1 mode unimodal, 2 modes bimodal, anything beyond that multimodal, no real modes, that's uniform. And then we talk about whether something is symmetric or not. If it's not symmetric, we say skewed. Is it going to be skewed towards your smaller values, the tail pulling towards the lower levels? Or is it be skewed right, so it's pulled towards the higher values? And then if you ever have unusual features, like outliers and gaps, you always want to make sure that you include those. So hopefully this gave you a chance to record just a little bit of notes so that when we get into class today, we can actually do the math with this. And please make sure you have your graphing calculators. It's going to be a bit of a process, but if you understand it now, it'll make the rest of the year go much smoother. Thank you.